So it is the first lecture of tensor analysis. So tensor analysis. So first of all, this tensor analysis is used in differential geometry and many other engineering applications. So what is the importance of tensor analysis? The basic importance of tensor analysis lies in the fact that tensor equations holds in all system of coordinates. So as we know that rectangular Cartesian coordinates xyz, polar coordinates, spherical coordinates, and cylindrical coordinates. So in these coordinates, the tensor equations holds in all system of coordinates, whether it is Cartesian, whether it is cylindrical, or whether it is a spherical coordinates. So that is the basic importance of tensor analysis. Now, in order to understand this analysis, there are some notations. Now, first, the main symbol is, remember, capital A, I, and J. This I is a superscript and this J is a subscript. So any indices which is at the lower part of the set, that is called subscript, that is in upper part of the letter, that is called superscript. So remember this notations. Now we know that the expression of this kind, the expression of this kind, a1 x1, a2 x2, plus so on an xn. So these are not the power, these are the superscript. So this is a1 into x superscript 1, a2 x superscript 2, an x superscript n. And this 1, 2, 3, and these are the subscript. So as we discussed here, okay, this I is a superscript and this J is a subscript. So remember this term. So in this expression, we can write this expression in term of summation. If we can write in term of summation, so it is a summation of AI x raised to power I, basically x superscript I and a subscript I. So remember this. Now, according to Einstein convention, what is the Einstein convention? In this summation, we can replace the summation part. So this term can be written as AI into XI. So we write the above expression that is in summation form, that is ai into xi. So a with subscript I and x with superscript I. Now this I which appear in two terms, so we will discuss in later terms. So these are the dummy indices. So we can replace these indices by j, k, and any other variables. It may be I, it may be J, it may be K, it may be P, it may be R. So it means if I running from 1 to n, suppose, then J is also running from 1 to n, and K is also running from 1 to n, and P is also running from 1 to n. So we can replace this I in term of J, K, and any other term. For example, AJXJ. So it means this is basically by Einstein convention. Basically, it is a summation of AJXJ, and this can be written in the form of summation. So remember this. This summation is basically this term, and this term is basically a summation. So here we used only one variable, that is a J. Now in this summation we have Aij xj. And here dummy indices is j. This is a dummy indices. So for fixed I, now for fixed I, this can be written as summation of j running from 1 to n. So aij x raised to power j. So this can be written as ai1 x1 plus ai2 x2 plus so on ai3, and here basically it is not 3, it is a n. So correct this term, this is a n. So ain x raised to power n. Now similarly in the other expression, here we have two variables, one is I and second is with j. So first we take summation in term of j, then in term of I. So that depends upon the value of I and j. So first take this summation. This is a summation of j running from 1 to n, or this can be written as ai1 xi1 plus ai2 xi2 and so on ain xin. So this is for every I running from 1 to up to n. So this I first it is for I equal to 1, second is for 2, and third is for 3, and so on up to n. So this product basically it is the double summation. One is with j, second is with I. Third, same. So this is xij and xgi. So that is only difference. Ij, or here it is a ji. So again on the same, it has two variable I and j. So first we take with the j for fixed I, then we will take summation with respect to I. So this can be written in this form, and this is for I equal to 1, 2, and so on up to n. So these are the basic convention of the tensor analysis. Above that, G alpha beta. Now alpha the beta is two variable x alpha x beta. So here we have two variable alpha beta. So we take two summation. This is alpha is running from 1 to 3, beta is running from 1 to 3. So in this summation, in this quantity, the given part is alpha is running from 1 to 3. So first we take alpha is running from 1 to 3, and this will become G1 beta x1 x beta plus G2 beta x square x beta plus G3 beta x cube into x beta. Now taking the second summation, that is with respect to beta. So this is again first term, second term, and third term. It means basically this term is double summation in term of alpha and beta into this values. So that is a Einstein summation convention. Now if f is a some function which depends on n variable, first variable, second variable, and nth variables. Now we differentiate, we can taking the differential of f. So we differentiate this function with respect to through x1, x2, and xn. So it means df can be written as curly f by curly x1 into dx1 plus curly f by curly x2 into dx2 plus so on up to curly f by curly xn dxn. This is by chain rule of partial differential equation. Now this can be written as summation of I running from 1 to n curly f by curly xi into dxi. So this I we can also written in term of j, we can also in term of k. So we can write in any of the indices. Now this can be written as by Einstein convention. This df is basically curly f by curly xi into dxi. So this is by summation convention of Einstein. Now, what is dummy suffix? So we already discussed in. If suffix occurs twice in a term, once as a subscript and once as a superscript. So remember, if suffix occurs twice in a term, once as a subscript and once as a superscript. Now, in this term, if we take, so I is occurs in twice. So I in the first term as a subscript, in the second term as a superscript. Yeah. So here it is in subscript, here it is in a superscript. So this is called a dummy suffix. If a suffix is not a dummy, in that case, that is called a real suffix. So what is suffix? Real suffix that is not repeated is called free or real suffix. For example, this is a AJXT. Now this J is a dummy because it appears in subscript as well as superscript. But R is real, so it appear in any part. Now here again ARS, so S is repeated. Now here it is R is a real suffix. So R is a real suffix. So that is our definition of real suffix. Now, next part is contravariant vectors. So that will be discussed in the second lectures.